module, you will study about relative velocity between two bodies in rectilinear motion. We know what displacement is. Now, let's understand what relative displacement between two bodies in rectilinear motion is. When several bodies move independently along the same line, time should be recorded from the same initial instant for all bodies, and displacements measured from the same origin and in the same direction. This implies that a single clock and a single measuring tape should be used. Let's consider two bodies, A and B, moving along the same straight line. At an instant, their position coordinates are x, A and x, B respectively. This implies that A is at a distance x, A with respect to origin O, and B is at a distance x, B with respect to the same origin O. This implies that the distance is measured with respect to the fixed point O, which is the origin. xB minus xa is the relative position coordinate of B with respect to A and is denoted by xB by A. When both A and B are moving, we take the distance at a particular instant. Differentiating relative distance xB by A with respect to time, we get relative velocity, which is denoted by VB by A. By differentiating, we get VB by A is equal to VB minus VA. Coming to the sign convention, regardless of the position of the origin O, with respect to the positions of A and B, a positive sign for xB by A means that B is to the right of A, and a negative sign means that B is to the left of A. A positive sign of VB by A means that when B is observed from A, the motion of B is in the positive direction, that is, rightward direction. A negative sign of VB by A means that when B is observed from A, the motion of B is in the negative direction, that is, leftward direction. This concept can be applied to determine the relative distance and relative velocity. Let us consider a few cases where two cars are traveling on a straight road with varying velocities. Case 1. Cars A and B are moving on a straight road with equal uniform velocity of 10 meters per second. At the time of initial observation, that is, when TB0 is equal to 0, B is 40 meters behind the crossroads, and A is 20 meters in front of the crossroads. What is xB by A and xa by B at time t0 equal to 0? Taking the crossroads as the origin O and time equal to 0, xB by A is equal to xB minus xa. This is equal to minus 60 meters. Minus sign indicates that the car B is on the left side with respect to A. xa by B is equal to xa minus xB. This is equal to plus 60 meters. Plus sign indicates that the car A is on the right side with respect to B. 2. What is xb by a and xa by b at time t equal to 5 seconds? Here, VA is equal to 10 meters per second. XAO is equal to plus 20 meter. TAO is 0 second and TA is equal to 5 second. We need to find XA. XA is equal to XAO plus VA into TA minus TAO. On substituting and simplifying, we get XA equal to plus 70 meter. Calculating for XB, here VB is equal to 10 meters per second. XBO is equal to minus 40 meter. TBO is 0 second and TB is equal to 5 second. XB is equal to XBO plus VB into TB minus TBO. On substituting and simplifying, we get XB equal to plus 10 meter. Now, calculating for XB by A, which is equal to XB minus XA. On substituting values and simplifying, we get XB by A equal to minus 60 meter. And calculating for XA by B, which is equal to XA minus XB. On substituting values and simplifying, we get XA by B equal to plus 60 meter. We observed that XB by A and XA by B are same in magnitude. This implies that the distance between the two cars remains constant irrespective of time elapsed from the first observation. What is the relative velocity of B with respect to A at time t equal to 4 seconds? We know that the values of t, VA and VB are equal to 4 seconds, plus 10 meter per second and plus 10 meter per second respectively. As the two cars are moving with uniform velocity, VB by A is equal to VB minus VA. By substituting and simplifying, we get 0 meter per second. When and where the two cars come side by side? By comparing the results of the first and the second bits of case 1, we can say that the cars never come side by side. Case 2. The position of the cars at initial observation being same as in case 1. Now, car A has uniform velocity of 10 meters per second and car B has uniform velocity of 20 meters per second. 1. What is VB by A and VA by B at time t equal to 4 seconds? As A and B are moving with different uniform velocities, the values of t, VA and VB are 4 seconds, 10 meter per second and 20 meter per second respectively. Here, VB by A is equal to VB minus VA. On substituting and simplifying, we get VB by A equal to plus 10 meter per second. Calculating the value of VA by B, it is equal to VA minus VB. On substituting and simplifying, we get VA by B equal to minus 10 meter per second. 2. When and where the two cars come side by side? When the cars A and B come side by side, their position coordinates with respect to the origin must be the same. That is, XA is equal to XB. This can be called equation 1. Here, XA is equal to XAO plus VA into T minus T naught. By substituting and simplifying, we get XA equal to 20 plus 10T. This is equation 2. Similarly, XB is equal to XBO plus VB into T minus T naught. By substituting and simplifying, we get XB equal to minus 40 plus 20T. This is equation 3. Substituting equations 2 and 3 in equation 1. On further simplifying, we get T equal to 6 seconds. This is equation 4. Further substituting equation 4 in equation 2, we get XA equal to 80 meter. The two cars A and B come side by side at 6 seconds when their position coordinate is 80 meters. Case 3. At the time of initial observation, that is, when T naught equals to 0, car A is 40 meters behind the crossroads and car B is 90 meters ahead of the crossroads. Car A is moving towards right with a uniform velocity of 10 meters per second. Car B is moving towards left with a uniform velocity of 15 meters per second. 1. What is VB by A and VA by B at time t equal to 3 seconds? VB by A is equal to VB minus VA. By substituting and simplifying, we get VB by A equal to minus 25 meter per second. Similarly, VA by B is equal to VA minus VB. By substituting and simplifying, we get VA by B equal to plus 25 meter per second. When and where the two cars cross each other? When the two cars cross each other, their position coordinate is the same. That is, XA is equal to XB, which is equation 1. Here, XA is equal to XAO plus VA into T minus T naught. By substituting and simplifying, we get XA equal to minus 40 plus 10T, which is equation 2. Similarly, XB is equal to XBO plus VB into T minus T naught. By substituting and simplifying, we get XB equal to 90 minus 15T, which is equation 3. Substituting equations 2 and 3 in 1, we get T equals to 5.2 seconds, which is equation 4. Substituting equation 4 in 2, we get XA equal to 12 meter. Therefore, the two cars cross each other at 5.2 seconds when the position coordinate is 12 meters. You have now reached the end of this module. In this module, you learned that relative velocity is obtained by differentiating relative distance with respect to time.